Good afternoon and welcome to the USDA Human Nutrition Research Center on Aging's Monday seminar series and our last seminar for 2024. We look forward to seeing you again in January when we'll resume our seminars. Before introducing today's speaker, I just have one minor housekeeping announcement. As always, we welcome your questions for our speaker, but I would like to remind you to ask your questions using the Q&A icon located on the webinar toolbar, not the chat box. And I encourage you to add your questions to the Q&A as they arise during the presentation. Today it gives me great pleasure to introduce our speaker, an HNRCA colleague, friend, and a fellow nutritional epidemiologist, Dr. Ardisson Korat, a scientist too at the HNRCA. Prior to joining us at the HNRCA in 2021, he earned a Master's of Science in Food Science and Technology from Cornell University and his Doctor of Science in Nutrition and Epidemiology from Harvard T.H. Chan School of Public Health under the mentorship of Frank Hu. He was a postdoctoral research fellow in cancer epidemiology with the Channing Division of Network Medicine at Brigham and Women's Hospital and Harvard Medical School as well. Previously, Dr. Ardisson Korat worked as a scientist in the food industry, leading projects to incorporate whole grains, fiber, and micronutrients into various food products, as well as successfully reformulating several product lines to reduce sodium levels and remove partially hydrogenated oils. He also led a collaborative research program to explore sodium reduction technologies in partnership with universities and private sector stakeholders. Dr. Ardisson Korat's current research focuses on food, nutrition, and geriatric syndromes with integration of metabolomic and other omic methods to better understand the metabolic pathways underlying these associations. He is currently examining dietary and metabolic risk factors of physical and cognitive function in cohorts of centenarians and individuals with extreme longevity in the New England Centenarian Study and the Long Life Family Study. Today, Dr. Ardisson Korat will discuss the role of diet in healthy aging based on insights from nutritional epidemiology. And with that, let me turn the microphone over to Dr. Ardisson Korat.
Thank you. Excuse me. Thank you, Paul, for the nice introduction. So today I'll be talking primarily about the role of diet in healthy aging using more traditional methods in nutritional epidemiology. So hopefully I can come back at a later point and talk about some of those other studies that I've been doing using some of the omic techniques. But again, I'm very happy to be able to share these results here at the HNRCA and the community who listens to our seminar. I think the last time I was here was before I was at the center, and I talked primarily about chronic disease epidemiology. So I'm very excited to show some of the results that I have on aging and healthy aging. Just to start, I don't have any disclosures. Most of the studies that I'm going to talk about have been funded by our cooperative agreement. And with that, I'd like to get a little bit more in the background. I think this is a slide that we use quite often at the center, since older adults are really the fastest growing group in the US, and particularly for people who are 65 and older, are expected to double between 2015 and 2050, which is a pretty staggering increase. And as we do that, we really need to find strategies for that aging to become healthy aging, as we know that older adults also disproportionately share the burden of chronic disease and declining physical who are 60 years or older. This is across the globe and primarily driven by cardiovascular disease, cancer, and other chronic respiratory disease. Another very important consideration is the decline in physical function. For instance, when we measure physical function in terms of frailty, which is a geriatric syndrome, which is characterized by diminished strength and endurance, which often leads to hospitalization and death. About 15% of adults are considered to be physically frail. And as you can see from the chart here, that prevalence increases pretty dramatically with age. And of course, cognitive decline is another condition that is pretty well associated with older adulthood, with, again, pretty dramatic increases with increasing age. And the burden of that is also expected to increase quite substantially in the next few decades around the globe. So I think this really motivates us to look for potential solutions and strategies that address more than one domain as a way to improve and promote healthy aging across some of these conditions simultaneously. For instance, we know that diet is a pretty well established and fundamental factor in the prevention of chronic disease prevention. This is data from the Global Burden of Disease report, highlighting diet as the second most important factor in the prevention of premature death around the globe. However, the comorbidities that are listed just adjacent to diet are also all modified by diet, including hypertension, high fasting plasma glucose, obesity, high LDL cholesterol. So as we think about this, we also need to find good dietary strategies to prevent physical function, and some of those have been identified, but are a lot less established than for chronic disease. And a lot of the research in terms of diet and cognition is really just emerging now. We're just beginning to understand some of those factors. So as I go through this presentation, I'll share examples of 3 studies that address some of these domains, hopefully simultaneously. So the first one is the role of dietary carbohydrate, quality in healthy aging, which is unfortunately just in time for the holidays, but it's still a very important thing to keep in mind, since carbohydrate represents the vast majority of the calories we consume. In fact, this study that was published about 5 years ago, looking at the macronutrient trends in the U.S. From Haynes in adults, found that our macronutrient composition tends to be relatively stable, with this very minute decrease in total carbohydrate intake, which has been substituted a little bit by increases in total fat. But what I thought was particularly interesting about this study is that they did find a very slow but significant decrease in the intake of what they call low-quality carbohydrates, so those carbohydrates from added sugars and refined sources, with a concomitant increase in high-quality carbohydrates, those from fruits, vegetables, whole grains, and legumes. And this is good news because carbohydrate quality has been associated with the prevention of chronic disease and premature death. However, we don't really know its role in the prevention of, in the promotion of physical function and cognitive function. And sort of that was the motivating idea for this particular study, where we wanted to look at the association of dietary carbohydrate quantity and quality assessed primarily in midlife with the likelihood of healthy aging. We use data from the Nurses' Health Study, which is a long-standing cohort of women, has been followed up now for almost 50 years with repeated assessments on health factors and diet. And for this cohort, there were assessments of healthy aging, which I'll go a bit more in depth in the next slide, in 2014 and 2016. And based on these assessments, the cohort has defined healthy aging as longevity in the absence of major chronic disease, good mental health, and no impairments in cognitive or physical function. To get a bit more in depth into these domains, for the chronic diseases, being free of the 11 major chronic diseases that are the primary causes of death and disability in the U.S., including cardiovascular disease, cancer, type 2 diabetes, was considered to be successful for that particular domain. For physical function, having no limitations on moderate activities such as walking or bathing, and not more than moderate limitations on vigorous activities such as running or lifting heavy objects, going up a flight of stairs, according to what the participants reported using the short form health survey 36, which is a common instrument in the study of the health of older adults, was one of the success criteria. So for subjective memory, participants who did not report any memory complaints in 7 questions about their change in ability to remember, for instance, recent events or short lists or spoken instructions, were considered to be successful for this domain. And those participants that scored 1 or less than 1 in the geriatric depression scale, which is an instrument commonly used to assess mental health in older adult populations, were considered to be successful in this domain. And as a reference point, anyone who reports a score of 5 or greater is usually followed up for any potential depression symptoms. For this study, we used a whole host of variables for carbohydrate intake, including total carbohydrate, refined carbohydrate, which included carbohydrates from added sugars and refined sources, carbohydrates from fruits, vegetables, whole grains, and refined grains. We also used a variable called high-quality carbohydrates that encompassed all of them. Dietary fiber, which we had the ability to look at total dietary fiber intake and also by sources. And in this presentation, I'll talk about 2 carbohydrate quality indices, the carbohydrate to fiber ratio, which was developed by the American Heart Association as a way to promote carbohydrate quality in the prevention of heart disease, but we evaluated it in the context of healthy aging, as well as the dietary glycemic index. So for our main analysis, we used the intakes that occurred when the participants were in midlife, so before they turned 60 years of age. And also we used, which also corresponded to the questionnaires that were furthest from the healthy aging assessments, which also helps to minimize reverse causation, which means that any intermediate outcomes that are developed over the follow-up, for instance, diagnosis of hypertension or hypercholesterolemia, tends to change the diets, and then those in turn tends to bias the associations. Now, we use a multivariate logistic regression adjusted for a number of covariates, including demographic, lifestyle, and health status variables. And of course, we conducted a sensitivity analysis looking at the cumulative average diets through 2002 or 2006, still leaving a lag to minimize that reverse causation as a way to represent long-term diets and minimize the risk of misclassifying those diets with only 2 questionnaires. So in our main results, the healthy aging assessments occurred when participants were between the ages of 70 or to 90. About 1/3 were free of chronic diseases. About 1 in 8 had no physical function limitations. About half had no reported memory complaints, and about 1/3 had good mental health status. So the overlap of these 4 domains gave us about 3,700 participants, from the initial about 48,000, which is about 7.8% of participants who met our definition of healthy aging. So in our main results, and just to orient you a little bit on these graphs, the associations above 1 indicate usually favorable associations with healthy aging. And then the main blocks show the PUN estimates, and the whiskers are the 95% confidence interval. So associations that are to the right of the dotted line usually mean favorable associations, and conversely for those on the left. So we observed that for every 10% calories of total carbohydrates, there was a 9% increase odds of healthy aging, which is a bit surprising to find, given that most of our calories come from carbohydrates. But we did find is that those participants with higher fiber intake, so those who consume fiber intakes above the median, were really the ones that were driving the associations for total carbohydrates, and those who consume fiber below the median showed no significant associations. High quality carbohydrates, again, those are the carbohydrates from fruits, vegetables, whole grains, and legumes, were favorably associated with healthy aging. And refined carbohydrates, again, those from added sugars and refined sources, were for every 10% in calorie increase in those, there was a 14% decrease in the odds of becoming a healthy ager. And in the table below, I'm showing the mean intake levels for those. So total carbohydrates was about half of the calories for the participants in the cohort, which tends to be representative of the US population. However, the proportion of high quality carbohydrates was close to 17%, which is a bit higher than the US population, which tends to be somewhere between 10 to 12%. For the sources carbohydrate sources that constitute these high quality carbohydrates, we observed overall favorable associations for all of them, including fruits, carbohydrates from fruits, vegetables, whole grains, and legumes. So about a 5% calorie per day increase in the first 3 is associated with about an 11 to 41% higher odds of healthy aging. the association for legume carbohydrates is expressed in 1% calorie increments because there's just so little that is consumed in the U.S. diet. And I have the mean intake levels in the table below. For our carbohydrate indices, we observed that higher carbohydrate to fiber ratio, which means that there's a lower proportion of fiber in the diet, was associated with about a 30% lower odds of becoming a healthy ager, and this is comparing participants in the top quintile versus those in the lower quintile. So this means that the metric that the AHA developed for heart disease prevention primarily can also be used in the context of healthy aging. And we did not observe significant associations for the dietary glycemic index. So to me, one of the most salient findings of the study was that fiber intake, and regardless of the source, was very strongly associated with becoming a healthy ager. Particularly fiber from fruits and vegetables. So for every 4 gram per day increase, which is a very modest increment, was associated with 26 and 21% higher odds of becoming a healthy ager. In this cohort, the mean fiber intake was about 16 grams per day. Thinking that most of the women in the cohort consume about 2,000 calories per day, they're really consuming about half of the recommended value per day. So I just inserted this quick slide from the current, which is about to be the previous guidance from the dietary guidelines for Americans, about 14 grams per 1,000 calories of food tends to be the recommendation. So thinking that for 2,000 calories, 28 grams should be the average. There's still a lot of room to go, which means that we can still explore associations in other populations that consume higher fiber contents to see if those continue promoting physical function and other components of healthy aging. While fiber intake has been increasing in the US, again, there's still a lot of room to grow in terms of our fiber content. And this will be exemplified in the next slide, in which we looked at the associations for fiber intake, looking at specific domains of healthy aging. And a reminder again, these are increments per 4 gram per day increase in fiber intake, which are very small increments. So very interestingly, all fiber variables except for vegetable fiber were associated with the absence of chronic disease. All fiber variables except for cereal fiber were associated with lack of memory complaints. And for physical function limitations and good mental status, we observed that every single fiber variable was associated with either lack of physical function limitations or good mental status. So this is the salience of this finding is that that fiber intake really influences health through multiple domains. And those tend to be a little bit differential. So a diet that has fiber sources from many different foods tends to be a good way to balance diet and beneficial for overall healthy aging. So some of the key points from this study is that carbohydrate quality is an important determinant of healthy aging. Carbohydrates from fruits, vegetables, whole grains, and legumes in middle adulthood were favorably associated with healthy aging in this large cohort of women. I should add also that the results from our sensitivity analysis looking at the cumulative average diets through 2002-2006 also showed very similar associations. In fact, a little bit stronger because averaging diets for individuals tends to reduce some of the measurement error. And dietary fiber was favorably associated with several domains of positive health status in older adulthood, which is a very important finding to be followed up in other cohorts. And in fact, we did run a preliminary analysis in the Framingham Heart Study, which has very detailed clinical assessments in that cohort, and we observed the same directional association between dietary fiber intake and the prevention of physical frailty in that group. So the results for carbohydrate intake in a way show the associations that we hypothesized. In a way, we know that higher quality carbohydrate was associated with better chronic disease outcomes. The findings for the other domains are encouraging. And so we use the same approach to look at the role of protein intake in supporting healthy aging, because this is a topic that has gained a lot of relevance in the last year or so. And we wanted to essentially apply the same methodology to look at protein and protein sources and the relation to healthy aging. Some background, these are results from a meta-analysis from 5 prospective studies in which the authors summarized the results. Again, these are comparing the categories for those people who consume the highest protein to the lowest protein, showing that total animal protein were associated with higher risk of all-cause mortality, and the associations here higher than 1 mean higher risk of all-cause mortality, versus the associations for plant protein, which seem to be going in the reverse direction. So there's this also highlights another important consideration in terms of human studies. And animal plant proteins come from relatively different dietary patterns and different food sources, which also tend to have an influence in terms of the association. The same associations are true for cardiovascular disease mortality in the same meta-analysis. However, we know from the literature in older adults that higher protein intake is associated with better physical function, and these are results from 2 separate meta-analyses conducted by the same group, in which they summarized in the first case the data from about 20 cross-sectional studies, and found that those participants who consume higher protein levels had better outcomes in terms of physical function as measured by the physical performance battery, walking speed, hand grip strength, and balance. Whereas higher protein intake was also associated with lower risk of physical frailty in a set of about 4 studies conducted, again, amongst older adults. This is also supported by one study that Denise Houston conducted now about 15 years ago, looking at protein intake and lean mass in older adults, finding that higher protein levels were more conducive to the preservation of both lean mass and appendicular lean mass. And interestingly, those associations were driven mostly by animal protein, because the results for vegetable protein were not statistically significant. So one of the aims of the study was trying to bring those 2 domains together. Is the chronic disease domain and the physical function domain going in different directions, or can protein can protein intake be associated in the same level across various domains? So the aim of this particular study was to apply the similar methodology to evaluate the association of protein intake and protein sources, again in middle age, with the likelihood of healthy aging later in older adulthood. And the protein variables we looked at were total protein, animal protein, dairy protein, and plant protein, knowing that animal and plant protein summed together constitute total protein, and dairy protein is a subset of animal protein. And we used very similar methodology where we looked at primarily the diets in midlife, also the ones that are furthest away from the assessments of healthy aging. And then we used the cumulative average diets from 2002 to 2006 to look at the effects of long-term diets on healthy aging. So our results in summary show that protein intake is favorably associated with healthy aging. So this graph shows the associations for a 3% energy increment in protein. So total protein was associated with about 5% higher odds of being a healthy ager, with about the similar direction for animal protein, slightly stronger associations for dairy protein, and then much stronger associations for plant protein, about 38% higher odds. And in the table below, I'm showing the mean intake levels for each one of the variables, and total protein intake for this cohort was about 18% of total calories. What I thought was particularly interesting was the differential associations we observed across the various domains of healthy aging. For instance, total and animal protein intake were unfavorably associated with the absence of chronic disease. So in a way, they're associated with high risk of chronic disease, which is consistent with the epidemiological literature in human populations. We didn't really observe any significant associations for dairy protein or plant protein in this cohort. We observed significant associations between plant protein intake and the absence of memory complaints, but not for the other protein variables. And very interestingly, and as we would have expected from our hypothesis based on the literature on physical function outcomes, all the protein variables were significantly associated with the lack of physical function mutations, which with much stronger associations for the intakes of plant protein. And again, these are increments of 3% energy, and the variables are adjusted for each other. So animal protein is adjusted for plant protein, and plant protein is adjusted for animal protein. And we observed that for mental status, plant protein was also favorably associated with having good mental health, but not for the other 3 protein variables. One of the advantages of doing this analysis as well as the previous results essentially modeled the associations of protein intake as we replace calories from everything else in the diet. One of the ways we can do this analysis is to model the associations of increasing protein intake at the expense of specific macronutrients, and get a bit more in-depth information as to what specific substitutions could drive or are driving some of these associations. For instance, increasing 3% calories from total protein at the expense of total or refined carbohydrates was favorably associated with healthy aging. We did not observe significant associations with whole grain carbohydrates. We did observe that increasing calories from protein at the expense of total fat, and particularly at the expense of trans fat, were associated with increased odds of healthy aging, but not with saturated fat or polyunsaturated fatty acids. And this pattern of associations became much stronger for plant protein, where replacing 3% calories from plant protein at the expense of all other macronutrients, including animal protein, was favorably associated with healthy aging. So some of the key points from this study is that dietary protein intake in middle adulthood is related to higher odds of healthy aging. The associations also for the long-term cumulative lab averaged protein intakes are similar in direction. And this differential associations of the various sources of protein, particularly animal and plant, may be due to the protein composition, but they're also very strongly influenced by the food matrix, since the sources tend to be very different, and then they usually tend to correspond to different dietary patterns. So I would say that future research needs to verify these findings in other populations and to elucidate some of these mechanisms underlying the observed associations. So these 2 studies looked specifically at 2 major components of the US diet. So in another study in which I collaborated, we wanted to look at the association of overall diet or dietary patterns as they support healthy aging. And this study was just accepted last week, and some of these results were presented at ASN this year. And in this study, we followed a very similar study design, and we coded 8 different dietary patterns. The first one, AMED, means the alternative Mediterranean diet, the alternative healthy eating index, a DASH, the dietary approaches to stop hypertension dietary pattern, the MIND score, which combines some elements from the DASH diet and the Mediterranean diet, a healthy plant dietary index, a planetary health diet score, and 2 additional scores, which are the empirically derived index for hyperinsulinemia, which is derived by correlating food groups with markers of C-peptide, for instance, or triglycerides over HDL, so markers of hyperinsulinemia. And the last one was the empirically derived inflammatory dietary pattern, which is derived by identifying dietary components that drive chronic markers of inflammation, including CRP and IL-6. And those 2 are reversed, therefore they are subscript, because the associations of those dietary patterns typically point to unfavorable associations with many health outcomes. So to adjust the direction of the diets, we reverse the scores of those. And now, for these associations, we found that all dietary patterns were associated with higher odds of healthy aging. And here I'm showing the associations for the extreme quintile, so those people who adhere the most to each one of the dietary patterns compared to those who adhere the least. And we found that all dietary patterns were associated with anywhere from 43 to 84% higher odds of healthy aging. And one of the things that I think is important to highlight here, so showing that healthy dietary patterns associated with healthy aging perhaps is not surprising. What I think is particularly salient is the magnitude of the association. So for most of these dietary patterns that have been evaluated in the context of all-cause mortality, the top category of adherence shows about a 30% benefit in terms of preventing the risk of premature death. So the fact that we're looking at associations in the 40 to 84% means that these dietary patterns are probably affecting multiple domains of aging, not only the disease prevention, but also other aspects of aging, which is something that we found in this study. The association, each one of these dietary patterns was favorably associated with each one of the domains of healthy aging, including good cognitive function, which interestingly, the strongest association was for a planetary health diet, good physical function and good mental health, which interestingly, the alternative healthy eating index showed the strongest associations, and the absence of chronic diseases, which was strongest for the hyperinsulinemia pattern. Again, the associations are consistent and strong. Just pointing out the associations for AHEI are about twice as strong in the participants who are in the top quintile of adherence to the diet, comparing those participants who are in the bottom quintile. And these are very consistent across the various domains. We also looked at the associations of the dietary components with healthy aging domains, because some of these diets essentially use some of these same food components coded in different ways, giving different weights to some of them. So as we essentially laid out the components that are encouraged versus the components that are a bit more discouraged, we found that intakes, for instance, of fruit, whole grains, a higher ratio of monosaturated fatty acids over saturated fatty acids, higher intakes of vegetables, unsaturated fat in general, various vegetable groups, nuts, legumes, yogurt and low-fat dairy, olive oil, polyunsaturated fats, and beans, for instance, were all favorably associated with healthy aging. And so the domains of healthy aging in various strengths. So the darker the shade of red or pink, the stronger the association. And in the same line, the increase of intakes, for instance, of sweets and desserts, sugar-sweetened beverages, snacks, refined grains, liquor, French fries, organ meats, processed red meats, saturated fat sources is unfavorably associated with healthy aging and with domains of healthy aging. And the strength of the association depends on the food component, the trans fat being probably the most harmful of these food components. So some of the key points from this study is that greater adherence to these 8 healthy dietary patterns was associated with anywhere from 43 to 84% greater likelihood of healthy aging. We did observe the stronger associations for HEI overall, but then each one of the domains showed a stronger association for individual dietary patterns. Also know that higher adherence to each dietary pattern is associated with the individual healthy aging domains in a favorable way, and that higher intakes of fruits, vegetables, whole grains, unsaturated fats, nuts, legumes, and low-fat dairy were associated with greater odds of healthy aging, and higher intakes of trans fats, sodium, and red and processed red meats were unfavorably associated with healthy aging. So a lot of these findings really look at associations of diets either in midlife or looking at the diets in midlife with some combination of diets in older adulthood in combination. So we also wanted to examine what older adults consume as a way to set the stage to also look for some of these potential outcomes in participants who are already in older adulthood, and especially for those participants who tend to achieve extreme longevity. So what are older adults eating? We have this report from the dietary guidelines showing that overall, the U.S. population is meeting, I guess, using the healthy eating index score in a scale from 0 to 100, we're somewhere in the 50s to low 60s, which again means that we still have a lot of room to grow in general in terms of adherence to healthy eating. The older adult group, those who are 60 and older, tend to have the best score of the population. However, we don't have a lot of information in terms of how that changes by decade of life, because as we know that the energy requirements for adults as they increase in age tend to decrease, and some of the food groups tend to change as they get older. So that was one of the ideas we wanted to look at in this study. Some of the primary groups that are not meeting recommendations in this group for the overall US population includes total vegetables, total fruits, and although the intakes of total grains seems to meet recommendations, the intake of whole grains is still below levels. The intake of total dairy is also below recommendations, but the intake of total protein foods seems to be meeting guidelines, which is good in terms of what we just learned about protein intake and healthy aging. On the other hand, for the nutrients that are encouraged to be limited, such as added sugars, about half of this population exceeds their added sugar limits. 80%, about 80% exceed the limits for saturated fat, and most people exceed their limits for sodium. So there's really not a whole lot of information in terms of not only what other adults eat, but then what drives lifespan and health span in this group. This meta-analysis was conducted about 2 years ago, trying to look for dietary patterns and survival to 100 years. And they didn't come up with any particular studies that have looked at that, but they did end up showing some of the results for younger populations. But essentially, there's very little that we know for populations that are long-lived. And we actually happen to work a lot with the New England Centenarian Study, which is a study of centenarians that began in 1995, precisely with the idea of discovering determinants of exceptional longevity. Genetics has been driving a lot of the findings from the cohort, but now we're really looking at modifiable risk factors, and amongst those, diet. The study has enrolled more than 1,800 centenarians, about 600 of their centenarian offspring, which are in age somewhere between 60 and 90 years of age, which they are considered older adults as well, and about 437 controls, which for the most part are the spouses of the offspring generation. And then annual questionnaires are used to update their medical history and their functional independence. And in one of those questionnaires, there was a dietary questionnaire that used the same Harvard Food Frequency questionnaire that is used in a nurse's health study. It was administered to a subset of participants, which included their offspring and their spouses, which amounted for about 463 participants. Interestingly, we had a really good split on gender, and then the age range was between 60 and 92, with a really good distribution in terms of marital status as well. So we use the Healthy Eating Index scores, and this is a project that was started first by Emma Schluter as part of her ALE capstone project, and now has been followed up by Erfei Zhao, who's a postdoctoral scholar in our group. What we found for the HEI scores is that they average about 70, and apologize, the numbers for the specific numbers are not showing in the table that I included. Which tends to be a little bit higher than the US population, but what's interesting is that in the study, it's not really different between the centenarian offspring and spouses, just thinking about whether there are any specific dietary factors that centenarian offspring may have over their controls or their spouses, but they seem to follow a similar dietary pattern. We didn't see any differences by sex, and we thought we would see differences by age group, but actually we see that at least in the overall scores, we do see relatively similar similar AHEI scores by age group. And then we don't see any major differences by education level or by marital status. When we looked at specifically some of the components, we did see that there's an opportunity to increase total vegetable intake, which was on a score of 5. Whole grain intake tends to be relatively low in this population. There's with an average of slightly less than 2 out of 5. Also, there's opportunity to include dairy, which also seems to be consistent with the dietary guidelines, and almost all other nutrients were a bit more close to optimal. I wanted to compare these results to a survey that one of my colleagues here, Dr. Kyla Shea, did using a sample from NHANES, also for older adults, which tended to have HEI scores somewhere in the mid-60s. They were not really greatly different between men and women, and it had really modest difference by decades of life. But what's interesting is that looking at the spider plots on the right, a lot of the same deficiencies tend to be present in the US population compared to the New England centenarian scores, so lower scores for greens and beans, slightly higher added sugars, good protein content, and low whole grain intake. We also looked at these results using the alternative healthy eating index, which is very similar to the HEI, except that it places a little bit more emphasis on whole grains, to have another way, and normally includes trans fats. And we also observed that the overall component score was about 50, which is not that different from adults who are in the same age range. Again, we didn't see any primary differences between centenarian offspring and spouses or men and women. We did tend to see a slight trend in terms of decreasing scores with increasing age, as in using the AHEI, and I think it was primarily driven by whole grains, which tend to decrease in intake with increasing ages. And also, we didn't see any major differences in bimarital status. So the next step obviously includes looking at specific associations between some of these food groups and longevity and healthy aging within this group. I forgot to mention that for the component-specific scores, we didn't see anything that's radically different than in the other slides. Whole grains seem to be one of the components that were still lower in intake, and there was a slightly higher intake of sugar-sweetened beverages and fruit juice. So some of the key points from this study is that the dietary scores in the New England centenarian participants were similar to older adults of similar age. These participants had overall low intakes of whole grains, nuts, and legumes, which is not different than the representative sample from NHANES in terms of greens and beans and whole grains. And the diet scores do not really differ by age group, sex, or marital or participant status. And really, our next steps will be to identify the contribution of these dietary components to lifespan and health span, and particularly taking advantage of the fact that this cohort has really well phenotyped information for the participants, and also some omics data, which we can use in conjunction with a separate study of older adults called the Long Life Family Study. So with that, I would like to start to thank all the contributors to each one of the studies, Erfei Zhao and Emma Schluter for the study on centenarians, all the rest of the people here at the center for their work and contribution on the studies on macronutrient composition, Paula Sebastiani, who has been my mentor in getting into a lot of the areas that are related to omics research that I hope to share next time, and also collaborators at Boston University, Stacy Anderson and Tom Pearls, who've given us access to the data, and also my collaborators at the Harvard T.H. Chan School of Public Health, with whom I've been able to do this work on healthy aging in a nurses study. I would also like to acknowledge the funding for each one of the studies, including our own cooperative agreement and one of the K grants that has supported me and funding for each one of the cohorts. And with that, I would like to thank you and maybe open the floor for questions.
Okay, we have a question in the queue, so let me start with that. Jean Dongwang says, great work, thank you. What are the potential mechanisms behind the differences of the beneficial effects between plant and animal proteins in your study? Is it likely because the plant-based protein sources have more phytochemicals, example, carotenoids and fiber, as compared to the animal protein sources, or because of plant protein itself, example, more complete essential amino acids?
It's a really good question, and it's a little bit difficult to completely parse out those differences in an epidemiological study. Some of that may be related to amino acid differences, and in fact, we would have hypothesized that the amino acid composition in plant protein would have been less favorable for physical function outcomes, given that they're not considered to be complete proteins. But that was not the case. So I think a lot of the differences we're observing have to do with some of the sources that they come in. Just thinking that animal proteins come primarily from meats and dairy versus plant proteins can come from legumes, nuts, a lot of wheat products which contain gluten, and which also tends to be a big contributor to protein in the U.S. diet in general. So I think some of that is also explained by the food matrix in which they come in, and a little bit of the dietary pattern that they come in.
Okay, the next question comes from Shelley Fong and says, thank you for your nice presentation. Is dietary fiber supplement intake also associated with healthy aging?
That's a really good question. We haven't looked at that specifically, and I think we have the data to be able to look at that. For the most part, the associations from fiber from whole foods has been the primary focus of this study, but I think it's something we can look at. I think some of the cohorts, again, because both the nurses and the New England centenarians use the same food frequency questionnaire, there's a question on metamucil use that we can look at. I would think that might go. I would hypothesize that association may go in very different directions depending on what the background dietary quality is of the participants. So if somebody's using the supplement to add fiber to the diet when they don't have a lot of background fiber, we may see interesting associations in the opposite direction. If there are supplements a healthy diet, we may see associations going in the same direction. So it's definitely something to look at.
Can I just follow up on that? Because you talked about the previous question about the importance of the matrix in terms of the protein, vegetable protein or plant protein, but isn't that true also for dietary fiber? I mean, shouldn't you have to consider the potential impact of the matrix? I mean, the idea that the supplement actually has no particular matrix relative to the foods, the vegetables and fruits and grains that you're getting the fiber from.
So yes, that's also a limitation of the intake of fiber. The way we have tried to look at it is also look at the associations by levels of diet or of healthy dietary pattern adherence, and we observe that they tend to be relatively consistent. But the problem is that dietary fiber comes from so many different sources that it's hard to necessarily adjust away things that are also coming in from fiber in the same way that it's difficult to adjust things away for the plant protein component. So I don't have a great answer for it other than we've looked at the association not necessarily controlled by the other elements, but also if it's modified by dietary quality or by other components in the diet, and we haven't seen major differences, but it's certainly something that is open for more study.
Okay, and next question comes from Roger Fielding. He says, very nice presentation. And he asks, are there any data available on total daily energy intake for centenarians?
We will have that data very soon. So the data set that we have from the New England centenarians, as I mentioned, only queried the offspring and the spouses. There's a separate cohort of which Paolo Sebastiani and Tom Pearls are co-PIs, and it's called the Long Life Family Study, and that one has data for all participants. So I'm waiting for the results to be available and for us to be able to analyze it, because that would be a pretty fascinating group to look at in terms of not only their energy intake but also their dietary composition.
Next question comes from Larissa Constantino, and she asks, how would you explain that total carbohydrates have higher odds for healthy aging than high quality carbohydrates?
Yeah, that's a really good point. I was expecting the high quality carbohydrates to have a higher association than total carbohydrates, and we've looked at it in a few different ways. We looked at total carbohydrates by glycemic index, by fiber intake. So it seems that it's the fiber intake and a bit of the carbohydrate quality that's driving it, but I can't really explain why exactly the total carbohydrates have a higher odds of healthy aging. And I don't know if it's a little bit of a statistical artifact of sometimes using odds ratios. Sometimes the subcomponent doesn't shows a stronger or weaker association. That's something that it's a bigger part of. So I don't have an incredibly clear answer on the difference between, I think it was 9% higher odds and 5% higher odds, other than the underlying fiber intake and glycemic index of the participants.
Next question is from Sarah Booth, and she says, great talk. As we age, our energy needs go down. Do you believe that micronutrient requirements set for individuals at younger age groups, hence higher energy needs, are applicable to the centenarians? And if not, how will you deal with the interpretation of the findings?
Yeah, that's an excellent question. I would expect that since their energy needs are decreasing and there's going to be specific needs that need to be fulfilled with that, with the more limited calorie intake, that we might need to pay attention to specific macronutrients. And the difficulty in looking at it is that aging tends to be very heterogeneous. So that's where a lot of our precision nutrition work really comes in, to look at potentially different different requirements for not only for different age groups, but different age groups that are with different health conditions that are aging in under particularly different trajectories. So I would expect that's going to be the case, and I don't know if that impacts our findings as of now, because again, we've looked at overall population findings, but I think the more we can look at subgroups of not only centenarians, but the offspring of their centenarians, to get some of this information, that would be definitely advantageous.
The next question is from Noel Henrik, and he asks, did you break up the fiber into soluble versus insoluble with a recommended ratio?
I did not. I have to look at, and I don't know if we have the data for soluble versus insoluble for all the participants. I don't think we had it available when we started the study. I have to see if it's something we can do, because that's another way of looking certainly at what the different sources of fiber are doing, since cereal fiber contributes mostly insoluble, for instance, and then fruits and vegetables contribute a mix of soluble and insoluble. That would be an important question to look at.
Next question is from Tomas Bitter, who says, great talk. The effect sizes of the dietary patterns are striking. I'm wondering at what points during lifespan healthy diet impacts aging the most. Did the individuals in the 100 plus cohort with good outcomes adhere to a long life healthy dietary patterns more than others?
Those are $2 million questions. I think we've looked at primarily middle adulthood as a potential important etiologic window for many conditions that occur in older adulthood. I don't know if that specific window has been defined, or if there are multiple windows, especially those that start later on in life. So that's an active area of research. I would love to continue doing work in that area to know. And especially for those participants who have extreme longevity, right? So just like the centenarians, did they have multiple windows during their lifespan where diet was particularly more impactful. And we don't know that yet. And the limitation to your second question is that we don't have the retrospective diet. So we know what they were consuming when they were centenarians, but we don't know what they were consuming when they were younger. One of the encouraging things, however, about the data set that we have in the New England centenarians is that those dietary intakes were collected in 2005, and a lot of the offspring of the centenarians have now aged into centenarian status. We'll have a little bit more information as to what that does. But in order to have that history of dietary intakes as it determines older adulthood, we need the more traditional cohorts to look at what people were consuming in their middle-aged adulthood and then in various decades of life.
The next question comes from Saidas, and she says, nice talk. There is large variability in most of the associations that you showed us. Is there work that you are doing or plan to do to understand this variability in risk or benefit using the information that's available within the studies you were looking at?
Yes, so that's always one of the things we want to follow up on. We did some initial work looking at variability by subgroups, which is what we can do with the data that we have from FFQs. We haven't seen much difference in terms of age or even levels, for instance, of physical activity that are particularly different. What I would love to do, which is the next stage of the work we want to do with the centenarian cohorts, those are very deeply phenotyped for various omics techniques, and I think that's going to give us additional insights, the interaction of diet with particular omic profiles, which may explain particular underlying health status or metabolic status as it relates to the outcomes we want to look at. I think that's going to be the next steps.
Okay. And the last question, I think it's the last question that I see here, is from Richard Alpert. And he says, great informative talk, thank you. And asks, is there any data that differentiates different sources of animal protein, beef, lamb, chicken, or fish? And then he goes on to say that comparing the effects of different levels of saturated fats from the different sources of protein, animal versus animal, as well as animal versus plant, would be revealing.
So not in the current data sets, because then the next step would be to analyze the associations for intakes of those particular food items. I don't think we have derived the protein intakes beyond what I showed in the study, and I'm sensitive to that point because I realize that animal protein may encompass everything from eggs to red meat to chicken to fish, and those individual food items may have differential associations with healthy aging within themselves. So that's something we can look at, probably looking at food groups separately, and then separating the effect of fat from the effect of protein is something I need to think a little bit more about, because they really come in together as a package. So it's difficult to adjust away one component without essentially mitigating the association for the entire variable that we're planning to look at. So it's a good question.
Well, that's all of the questions, I believe. So I want to thank you for a very interesting talk, and look forward to seeing some of the future research coming out of this.
Thank you so much.